Hello and welcome to the second part of 5G TDD measurements with SignalShark. Now we would like to look at making a signal under signal visible. The TDD transmission principle can be very useful for finding interfering signals. If the base station is not transmitting during the so-called uplink, the interfering signal should be easily recognizable. In time-gated measurement mode, for example, SignalShark can provide us with measurement results only during the uplink. It suppresses the results of the downlink. This results in a much clearer display. In contrast to part 1, we are now using a handheld device. In opposite to the rooftop station, this allows us to feed an interference signal from a generator into the signal path of the antenna without coming into conflict with the mobile radio. What we took from the first part is that we have Telecom's 5G signal in TDD mode at 3.65 GHz. This is a system with a width of 90 MHz and a repetition rate of 20 milliseconds. And the uplink is in the time domain at the end of the frame. We see the signal in the scan spectrum in the center of the screen. To the left is another 5G channel, to the right it's unoccupied. Now we switch on the generator. At first place the signal is above the 5G signal at 3.72 GHz. A continuous wave signal would be too simple. So we switch on the pulse modulation so that the generator signal is more similar to the wanted signal and can hide itself better. And to make it even more difficult, we let the generator sweep. In other words, it's permanently changing its frequency. The signal then appears similar to a frequency hopping signal, an interference signal that you really don't like to see. Now we are moving it into the frequency range of the 5G signal. We can only see it easily because the level of the interfering signal is still significantly higher than the wanted signal. So we lower the level of the generator by 30 dB and the signal is gone. Only when the 5G signal is under little load could we detect the signal with a normal real-time analysis. If there is a lot of traffic, this interference signal is virtually undetectable. Now the time has come for time-gated measurement. We open a new task. We adapt our center frequency Then we set the channel bandwidth to 40 MHz as we want to search for a signal, and set the recording duration to 20 milliseconds as we learned in part 1. In part 1, we simply selected the time range using zoom. This can be done more precisely with the markers, which are already activated here and assigned to gate start and gate stop functions. A look at the setting or definition of the mobile radio system tells us exactly when the time slot of the uplink or the guard interval is. These can now be precisely controlled with the markers. And with this method, we also have the advantage that the entire frame remains visible in the IQ magnitude. We now switch on the gate in the trigger menu, and the IQ spectrogram will only display the signals during the uplink. Optimize the level range a little, and we get our hopping signal displayed perfectly. The first and most important step for the interference search is done. We have extracted the interferer and made it visible. And since opening the new task with the default setting, just 2 minutes and 30 seconds have passed since we had the setting for the time-gated measurement. Well, we knew the interference frequency. If we wanted to scan the entire 90 MHz, this can be done quickly with the 40 MHz real-time bandwidth of SignalShark. If you go to the spectrum display and select an f-step of 30 MHz, for example, you have enough overlap between the measurements. Now select f-cent and move one step further with the rotating wheel. The f-cent jumps from 3.68 GHz to 3.65 GHz, and you can see that the interference signal runs out of the spectrogram to the right. Another step, and you can see in the spectrum that we are now at the lower limit of the operator. As mentioned already in part 1, all 3 GHz 5G TDD systems here in Germany are in the same TDD clock. So we can easily drive through the whole band N78 with the f-step and also look into the uplink of Vodafone and the other operators without changing the setting. It could hardly be quicker or easier. Now it's your turn. Why not give SignalShark a try? Or if you already have one, the time-gated measurement option can be added on site. No hardware required, simply updating the firmware and purchase and activate the option. And if you don't have a 5G TDD service on site, it also works with 4G TDD too. Good luck now with SignalShark, your Narda safety test solutions.